What's in the Water by Bailey Schatzel for the purpose of Chemistry 120N, Lab Section 2. Water is around us everywhere, so it is important that the quality of water that we are consuming is safe and clean, and that is not always the case. The purpose of this lab is to identify unknown compounds in various drinking water samples. The sample that I will be discussing is sample C, which is also known as vial 31. The technology used was NMR and IR spectroscopy. The NMR shows the number of peaks as well as the ratio of areas, whereas IR shows the possible functional groups. Here to the left, you can see an NMR spectrometer, as well as below it is an IR spectrometer. Just for some more technical terminology, for the NMR, we use an Ensazi instrument-inked EFT60 NMR spectrometer that had a 1.4 Tesla permanent magnet that operated at 60 megahertz proton frequency. It also had PNMR spectrometer control and data acquisition software that used one proton scan. And then lastly, NUTS Pro software was used to display the spectra. For the IR, we used a Thermo Scientific Nicolette IS5 FT IR spectrometer with ID7 ATR that had a volatile sample cap. It also had a diamond crystal ATR sample accessory with a metal cap. And then Omnic Instrument operating software was what displayed the spectra, which produced 16 sample scans. For the procedure, first the IR spectra was taken and the functional groups present were recorded. Then the NMR spectra was taken and the peaks and ratio of areas were displayed. Tables and figures of both were created. And then the results from the IR and the NMR were then compared in order to identify the unknown compound. So first we have the possible compounds produced by the IR spectra. So for example, if you have an OH group and a CH single bonded carbon, you might have methanol, ethanol, 2-butanol, or 2-propanol in any of your samples. So this is pretty broad, but it'll get narrowed down. So for my IR spectra, we have in this range from 3500 to 3100, we have an OH group. And then from 3010 to 2800, we have a CH single bonded carbon. So again, as I just mentioned, all of those possibilities, which were 4, that is too broad to determine which compound is in sample C. Therefore, we go to the NMR, and that will help us narrow down our choices. So here is a table depicting all of the possible compounds with their corresponding number of peaks and ratio of areas. So for example, if there's 2 peaks with 3-to-1 ratio, one of your possibilities might be methanol. So for my sample, I had a 6-to-1-to-1 ratio and there's 3 peaks. So this information is compared to the previous table, and I was able to narrow down my choices. So again, for the IR, Table 1 and Figure 1 were compared. The functional groups that I had in my spectra were OH and a CH single bonded carbon. So the possibilities in correspondence to Table 1 were methanol, ethanol, T-butanol, and 2-propanol. Again, that was not enough information to determine the compound, so I went to my NMR, where Table 2 and Figure 2 were compared. I had 3 peaks with a 6-to-1-to-1 ratio, and the only possibility that had that information was 2-propanol, which was also in my IR. So therefore, I know that the identified compound was 2-propanol. So according to the health risks of isopropyl alcohol, 2-propanol in drinking water might lead to slowing of the heartbeat, nausea, stomach pain, confusion, dizziness, low blood pressure, respiratory irritation, central nervous system depression, dilation of the blood vessels, vomiting, and disturbed motor responses. As one may be able to tell, that is not benefiting someone's health, whereas it's more detrimenting someone's health, so it is not safe in our drinking water. Furthermore, according to safety data sheet, sample C can be harmful to the environment due to its high flammability and its mobility due to volatility. So that is just when it's able to spread throughout the water very quickly and it's not able to be contained, which makes it more dangerous, because if we can't get control over it and it's able to spread more, it's going to cause more effects. And so in order to use it, explosion-proof electrical, ventilating, and lighting equipment is advised. Just in conclusion, the quality of our drinking water is important when considering human health, as well as surface area water to the environment. So IR and NMR spectroscopy technology is able to help us determine the quality of our water, which again can lead to finding the quality of our water, such as the hazards of 2-propanol. These are my references. Thank you for your time.